Classification of matter. Well, first of all, what is matter? And that's a different question than what is the matter, right? What's the matter? Oh, I'm sad. What is matter? Matter is anything that occupies space and has mass. Your textbook, your desk, your pencil, your car, all of these things are matter. Anything you could put a sticker on, definitely matter, okay? But air, is air matter? Yeah, it is. It occupies space, and it doesn't appear to have mass, but it does. If we look at a particular type of matter, that's called a substance. So substance is a very general term talking about one type of matter, a substance. Scientists like to classify things. I mean, what do you do with overwhelming amounts of information? You start breaking it into groups and organizing it. So matter, there's a lot of different kinds of matter, and so we group it into different categories. It's a little bit like, taking motor vehicles, right? And you can categorize them in different ways. You can say, okay, well, this is a subcompact, a compact, that's an SUV, that's a pickup. You could categorize them by color, by make, by place of origin, by how many wheels they have. You could categorize them in many different ways, and which method of categorization you use depends on what your purposes are. And so we have a similar thing for matter. So one way to classify matter is according to its state, its physical form. And another common way is by its composition. What are the basic components that make up that matter? So the states of matter. There are 3 states of matter. There's actually 4, but we're not going to talk about plasmas. Solid, liquid, or gas. And this classification is based on the properties it exhibits. And as you probably know from experiences with water, the state of matter changes from solid to liquid to gas with increasing temperature. Think of an ice cube. Take an ice cube out of the freezer and you stick it in the parking lot today. It's going to melt, and then it's going to disappear. Did it really disappear? No. The water that was solid in the ice melted into liquid water, and then because of the heat, it's supposed to be 109 today? Yikes. The heat, it causes it to vaporize, to evaporate and go into a gas, and then it floats away. So 3 states of matter. We'll just go over this kind of quickly here. Solid matter. We have the atoms or molecules packed in close together to each other, and they are in fixed locations. If I jump back to this picture, this is an illustration of matter in the solid state. All of these little atoms represented as spheres are tucked in right next to each other, and they're not moving around. The atoms and molecules in a solid do move, but they don't move relative to each other. They just vibrate in place. So, did you know that students come in 3 different states? Solid, liquid, and gas? You are currently in the solid state of students. We're in here relatively close together, and none of you are moving around the classroom, right? You're sitting in your seats, and we're actually fairly well organized here today. But are you moving? I hope so. I hope you're breathing at least, right? Even if you're snoozing. But you're all moving, but you're not moving relative to each other. And that's what particles in a solid do. They may vibrate and wiggle because they're fidgety, just like humans are. They have to be moving, but they're not moving relative to each other. So because of these properties, a solid will have a fixed volume and a rigid shape. You know, my cell phone is a solid, right? So if I put this in a beaker or I set it on the bench top, the shape doesn't change and its volume doesn't change. Examples, ice, aluminum, diamonds, there's lots of examples of solids. We can take solids and divide those into two general categories as well: crystalline solids and amorphous solids. So a crystalline solid is something where the individual particles, atoms or molecules, are in patterns with long-range repeating order. And so here's an illustration of a diamond, which is a crystalline solid. And the carbon atoms are arranged in a particular order, and that order persists all the way through. So this, with students, is sitting in chairs in rows at desks, right? There's an order to it. Table salt is crystalline, diamond, crystalline. There's lots of other examples of crystalline solids. Amorphous, we have a lot of prefixes and suffixes that we use in the English language and especially in science. The prefix a means without. When you think of morph, what does a superhero do when he morphs? He changes shape, right? So this is amorphous, means without shape. It doesn't have a well-defined shape. Glass, plastic, rubber, these are substances where the individual particles are just kind of all jumbled together. So for students, this might be like in a kindergarten classroom where you have all the students come and sit down for story time. Do they sit in neat rows? No. They sit down, and if you're lucky, they stay seated, right? But they're wiggling. They're not moving relative to each other, but there is no order. That's an amorphous solid. It's not well ordered. And there's many different ways that those things can be ordered, but we won't talk about that now. Liquid. So in liquid, the atoms or molecules are packed almost as closely together as in a solid, but now the particles are moving relative to each other. So during lab, students are in the liquid state because you're not going to be just sitting there. You're going to be getting up and using the balance and going over to the hood and getting sodium hydroxide from the back counter. And we'll be moving around, but we're still close together. Liquids have a fixed volume, but not a fixed shape. If you take a cup of water and pour it into a shallow bowl, its shape will change. The volume doesn't change. When you pour it back into the 1 cup measure, it's still the same volume. If you pour it into a tall, skinny container, it will take on the shape of the container. Its volume changes, its shape changes, its volume doesn't. Water, alcohol, gasoline are substances that are liquids at room temperature. Gaseous matter. So in a gas, the atoms or molecules have a large amount of space between them. So gas state for students is when class is over and you guys go out the door and you scatter. You go off in all different directions. You basically have no relationship to each other at that point. There's space between you and you just go off independently. Gas particles are free to move relative to one another, and they are not very close to each other. And that's what makes gases compressible. Solids and liquids can't be compressed, not to any significant degree. So here's an example. If you put a solid inside of a piston here, and you push down on this, you can't squish these any closer together. They're already touchingly close. They can't be squeezed closer together. But if you put gas into a piston and you press down on it, it can be squeezed together because there's a lot of empty space in a gas. And so that's how we can take helium and squeeze it, compress it into a cylinder, and then use that small little gas cylinder that you get at the party store to fill up like 30 party balloons. The volume of that gas has changed because you released it from its compressed state into the balloons where it is less compressed. So gases are compressible. Any questions about that method of classifying? We can also classify matter according to its composition, what it's made of. Here's a flow chart that kind of gives an overview of what we're going to talk about. Elements, compounds, and mixtures. So matter as a whole can be divided into mixtures and pure substances. Mixtures can be divided into heterogeneous or homogeneous. Pure substances can be divided into elements or compounds. So we'll talk about each of those. Pure substance versus a mixture. In a pure substance, there is only one type of particle in the substance, and it doesn't change. So a pure substance, you can take a little piece of it from one side, a little piece of it from the bottom, and if you were able to zoom in and look at the particles, you'd see that all the particles are the same. In a mixture, you have two or more components. So, like with Legos, a mixture of Legos might be some red bricks and some blue bricks. You got 2 by 2 red bricks and 2 by 2 blue bricks, and they're all mixed up together. That's not a pure substance. A pure substance would be if they were all the red 2 by 2 bricks. With a mixture, the proportions of the components can vary. You could have a whole bunch of blue bricks and just a few red ones, or you could have a lot of red ones and a few blue ones. You could have equal numbers. The proportions can vary, and that's an important characteristic of a mixture. The pure substances are divided into two different types, elements and compounds. And this is based on whether or not those individual particles can be broken down, taken apart, decomposed into simpler substances. Yeah, I'm going to draw you a little picture here. You'll learn very quickly that I'm not an artist. So, we could have a pure substance that is made up of little red Lego blocks. We can also have a pure substance, just bear with me here, that is made up of these little tiny creations. A blue brick stuck to a red brick. Every particle in this substance is the same, but these little particles could be taken apart, right? You could separate the blue and the red from each other. Over here, you've got individual Lego bricks. You can't take apart a Lego brick with your bare hands. You just can't. Now, you could cut it with a hacksaw, but that's not what we're talking about. So this cannot be broken down. So that's going to be called an element. And these can be broken down, and these are compounds. Of course, the particles we're really talking about here are atoms. So these would be individual atoms, and these would be molecules. Molecules are atoms that are stuck together. But each of the particles is the same. So this could be perhaps carbon monoxide with 1 carbon and 1 oxygen. And the carbon and oxygen can be separated from each other. So an element cannot be chemically broken down into simpler substances. These are the basic building blocks of matter. And so you're going to have one kind of atom, such as helium, and it's just all helium, and you can't break those individual particles into anything smaller. Compound has 2 or more elements. What makes this very different from a mixture is that it's a fixed, definite proportion. When you have carbon monoxide gas, it's always 1 oxygen to 1 carbon, always. If it was a mixture, that proportion could vary, and you'd have different types of particles. Carbon dioxide is always 2 oxygens to 1 carbon. The proportion is always the same. Now, most elements are chemically reactive and will react and combine with other elements to form compounds. That's why we see very few atoms free in nature. They're mostly combined with other things. So water, sugar, they will combine with things. Any questions about that? Mixtures. Remember, a mixture had at least 2 different types of particles, and the composition could vary. We can divide mixtures into 2 different categories, heterogeneous and homogeneous. And again, we have prefixes, and the prefixes tell us something. Hetero is a prefix that means different, and homo is a prefix that means the same. So Homogeneous mixtures are the same throughout. Heterogeneous mixtures have different sections, if you will. So this categorization depends on how uniformly the things in the mixture mix together. So a heterogeneous mixture, the composition can vary from one region to another. It's got multiple substances, and the presence of those substances generally can be seen. So if you take salt and sand and mix them together, you can mix them all that you want, but when you spread them out and look at them very carefully, you can see, oh, that's a salt crystal, this is a piece of sand. They're two distinct parts. Chocolate milk is a heterogeneous mixture. You pour Hershey's syrup into a glass of milk, you stir it up, you're like, oh, delicious chocolate milk. What if you leave it sitting there for 5 minutes? What happens to the chocolate? It sinks to the bottom, and you have to stir it up again because it's not a homogeneous mixture. You've heard of homogenized milk? If you have raw milk and you let it stand, all the fat rises to the top. We're used to homogenized milk. We would think that's kind of yucky, right? Homogenizing milk is a process that makes milk homogeneous so that your whole milk can sit in your refrigerator for a week and you don't get a layer of cream at the top. It stays homogeneous. So a heterogeneous mixture has different distinguishable parts. Macaroni and cheese. There's the noodles and there's the cheese sauce. Vegetable soup. You can see the different chunks of vegetable, and there's the broth. It's heterogeneous. Homogeneous has multiple substance, but it appears to be a single substance. Sweetened tea. So you take a cup of tea and you put some sugar in it and you stir it up. Now you have sweetened tea. If you wait 5 minutes, does the sugar settle to the bottom? No. No, it doesn't. Not if it dissolved. It's the same throughout. It's very intimately mixed on the level of the individual particles. The top of the tea is just as sweet as the bottom of the tea. So homogeneous mixtures are uniform in their composition because those individual particles mix on that level of the particles. They mix uniformly. Mixtures can be separated because the two or more substances in that mixture have different properties. And so we can make use of the differences in the properties to separate them. Sometimes we use different physical properties, sometimes we use different chemical properties. A very simple method of separating is called decanting, and we will probably be doing that in lab. If you have a mixture of sand and water, you can separate that by carefully pouring the water off, because you have a liquid and a solid. And if you carefully pour the water off, you can get pure water separated from the sand. Another technique is called distillation. And this is a way of separating homogeneous liquids. So, if you're going to make whiskey or something, you get the mash in it all, you get this chemical reaction and everything going on, and you've got this mess, and then you want to get the alcohol out of it, right? You want to separate the alcohol from the water and the other substances. So here, if we have, what is that? This is mixture of liquids with different boiling points. So say we had alcohol and water mixed together. Alcohol boils at a much lower temperature than water does. So if we heat this mixture, the alcohol will go into the gas state at a lower temperature than the water. And the alcohol will go into the gas state and try to escape, but we want to collect it. So we're going to run it through this condenser. It's got an outer sleeve that you run cool water through to cool it down. When you take a gas and you cool it, it becomes a liquid again, and this is slanted, and so then the liquid drips and collects over here. And you can separate the alcohol here from the water in the mixture. And that's called distillation. Separating liquids based on differences in boiling points. And that's That's how they separate crude oil into, diesel and gasoline and all the different grades of petroleum products. You can also use filtration. I made spaghetti last night. I did a filtration in my kitchen, right? If you made coffee this morning, you did a filtration. If you have an insoluble solid and a liquid, you can decant, but you can also filter. So in chemistry, we use a glass funnel and a piece of paper that's much like a coffee filter. You pour the mixture of liquid and solid into the filter paper. The liquid can pass through, but the solid particles get trapped behind, and then we can separate them. This is separation based on physical state. One's a solid, one's a liquid.